How's it going, everybody? Welcome back to Make It and Break It. This video is actually a replay of a stream I did on Twitch where I was going through and doing a bunch of CAD work, and I wanted to show you guys the kind of background behind that. So hopefully you find this entertaining and informative as I go through some interesting CAD work to try and update our HyperTenere foot controls to the new designs. So enjoy! What's up, everybody? This is the kind of first stream attempt on the Make It and Break It YouTube channel. If you Make and Break YouTube channel, this is the Twitch channel, Make and Break It Twitch. If you haven't seen the YouTube channel at all, hi, my name's Andrew. I run the Make It and Break It YouTube channel where we do kind of 3D printing, design, taking advanced manufacturing, 3D printing stuff, and bringing it into your home garage, including working on motorsports builds and stuff like this. So this is some of the stuff we've done. This is a fitting fixture for a skid plate for a Yamaha R6 we're turning into an adventure bike. And today I just figured I'd stream as I try and figure out better ways to make this part here. So this is for that same 99 Yamaha R6. It's kind of your standard sport bike. Let's see if I can get a picture of it from here somewhere. Yeah, let's pull one of these pictures somewhere in here. I have like far too many pictures now. We can get rid of that. But it's my first motorcycle, actually. So it was a 1999 Yamaha R6 I bought 6 or 7 years ago as like my first motorcycle, and I've had it around forever, but it really doesn't get a whole lot of play because like if I'm riding around on the street, I'd rather ride my Ducati Street Fighter. So I've been getting into kind of dirt biking, and let's maybe pull this a little bit closer. My mic stand is not the best, but I've been getting into off-road riding and adventure riding recently, and so I figured, well, it's going to cost me a bunch of money to get like a big adventure bike that I can go take on long road trips, but I've already taken the Yamaha R6 on a bunch of road trips. Actually, this is where I can get some pictures from that. We'll go on to my personal Facebook here, and go way back. So we scroll through a bunch of this stuff, but so I figured why not just turn it into an adventure bike itself. I run a YouTube channel where we do motorsports builds anyway, so sounds like a fun build. So we've been working on this for a while, and among many of the things you have to mess with in order to get a Yamaha R6 to be comfortable for a large guy like me to go off-road is you have to get foot controls and crash protection and a bunch of stuff on the bike so that it's like not just going to immediately explode as soon as you hit the ground. So the plan here, at some point I will hit it again, is to take this. This is the version 7 of our right side foot control mounts. And I've been trying to get this into a position until recently. I've been working on getting this in a position where it sits comfortably. Yeah, this is a good picture. Maybe if it ever resolves. Come on, boys. There we go. So this is the bike we're talking about. I've taken this bike right down in here on several road trips, and this one was to I took 3,000 some odd miles through the redwoods and everything else. So I've already taken adventures on it, so now it's just trying to turn it into a true adventure bike and let me go wherever I kind of want to go. And we can close that now that it's freaking out about it. So, that brings us here. These are the foot controls that we've mostly okayed. There's a YouTube channel, Make It and Break It, where we've been covering a lot of this stuff, and we've been test fitting it, and our final test fit on this specific design, this is like the 6th or 7th iteration of our prototypes design. Everything seemed to fit pretty good, so we know that everything's where we want it. It's now time to get it down to manufacturability, where we're worried about getting this manufactured in a reasonable cost. And right now, you can see what this thing might... Well, actually, this is not working. But, and these guys don't want to give me an analysis right now because the model isn't perfectly how they want to, how they would want it to be. So right now, this thing would cost, if I were to send out like a Xometry, Plethora, one of those on-demand CNC type places, it's going to cost on the order of $400 to have this piece CNC'd out of steel. And more so if it's aluminum, sort of roughly similar depending on the type of stainless. So we're probably going to make them out of steel and just paint them or something to not have to deal with galvanic issues when we have it installed. But it should be able to make this pretty cheap. So a flat version of this without this protrusion here, which is our foot peg mount, and with a flat version of this where it didn't stick up nearly as much, this is where our brake master cylinder will mount. So our feet come down over here, our brake master cylinder mounts here and here. A flat version, this was like 3 or 4 versions ago before I started really getting all the clearances correct. A flat version was like half that much, maybe $200, $180 to go get CNC machined on demand. So I think we can get this piece into a position where it is actually like in that sort of realm to build by actually breaking this up into 2 to 3 pieces. So part of what makes this difficult to manufacture is that it is actually very thick. So it's got to come from a pretty thick piece of stock in order to manufacture. And if you want to manufacture from thinner pieces of stock, you actually have to manufacture... It takes longer because you have to, like, you know, machine this side and then this side. Whereas if you want to minimize machining, you have to do a pretty thick, like 2-inch, 2.5-inch thick piece of plate, throw it in a CNC, machine all this down, flip it over, machine all this down, and then you're probably pretty close. You will probably have to hand drill or, you know, put it on a 5th axis to get like this hole here. Uh-oh. I think we just broke it. But so we're going to try and simplify that. And the way we're going to do that, there we go, is we're going to try and split this off into multiple pieces. So the kind of idea here is if we split this bottom piece off and this upper mount for the brake master cylinder here, so if we split this upper mount off and just have it sit on standoffs or something like that, that go down and get bolted down to this piece here, then we might actually be able to save ourselves a lot of money on the machining process. So that's kind of the idea here. At least I think it is. So this is not going to be the prettiest. This is not how I would necessarily suggest you do this. This is the computer-aided design version of spaghetti code. If you're a coder and you want to know what, or if you're familiar with coding, spaghetti code is just like horribly unoptimized coding. It's basically every game that has like bad netcode is just like spaghetti code, and it's not optimized for making changes or anything like that. So this design is also not optimized for making changes. It does take a while to do that, but figured I'd just sit here and have some fun and stream it, and at the worst case scenario, this will find its way onto YouTube at some point, and people can see what goes on behind the scenes here when I'm messing with CAD and spending hours and hours and hours trying to design things. So, where are we going to go? Oh, we need to get some music going. So this is, hopefully, this is copyright free. They say they're copyright free, so we'll see how it goes. And all right, so music's going there at this point, and let's get started. So I think first what we want to do is we're gonna go in here and save a bunch of versions of this so that we can actually modify it without ruining our original piece. So let's save as this is not prototype. We're gonna call this is actually we're gonna call this. These are actually our production models here. So and this is going to be right side mounts. Is going to be main plate, which is going to be the major plate, this kind of like big flat piece that we're going to end up with. And then we're going to have master cylinder mount. And then we're going to have foot peg. Cool. Alright, so we're going to save this as main plate V1. And we're going to save a completely different version. No, we're not going to save a different version. Here's what we're going to do. So if this is main plate V1, we want to get rid of basically, yes, get rid of all this. We're going to get rid of everything that protrudes up. So we can go get rid of that. Don't need that sketch. We don't need those. Let's see. In truth, we don't really need this whole entire extrusion. Yep. Oh, I needed that extrusion. these are the mounting ears for our foot pegs. Alright, let's see what's wrong with this now. So this is the first step in fixing our setup here. Not gonna need that fillet. Yep. Not gonna need that fillet. So the sketch isn't the issue. We shouldn't need that cut. So we can delete that. That looks like it was the... I do need that one though, because that is a clearance cut on either side for the ground. Where possible, we try and keep that clearance. And what's this sketch? Oh, that's that. Okay. Yeah, I don't need that either. We're gonna leave that one. That's an indicator sketch here. So we'll leave that. Rebuild everything. So now we have our piece here that we like. This revolve is also going to go away. Yes, go away, please. And then this fillet is going to go away. And then let's see. What are we gonna do here? Can we defend the land we conquered back in high command? I don't wanna be the only driver. Don't forget to save your work, kids. I've had to redo several hours worth of CAD work in this thing before. Let's see, so there's gonna be another fillet. We'll get rid of that fillet. Yes, I don't need you anymore. Don't tell me, I'll find a way. Don't break me, I'm here to stay. something wrong with this reference. Oh, we don't need that clearance cut anymore if we don't have that bevel. That's right.
Settle for the last remaining dancer. Can we take flight and do what's right? Damage the side of modern life. Don't wanna be the lone survivor.
Alright, so what if we took this main boss here?
Don't tell me I'll find a way.
Nope, I didn't want to edit that sketch.
Don't break me.
I think what we want to do is adjust this. How is this thing set up? I forget. What if I just made this 0.5? This cut. Those are no longer necessary to cut for clearance. Alright, so this is where we need to do a lot of work. But you can already see we're doing a really good job of simplifying our piece here. So now this is much simpler and easier. To be honest, you could just cut this out of plate, half-inch plate probably, and then just really take your time locating these holes. Oh, hold on. There's a cut in here. Let's open all this stuff back up and see where we're at. Yeah, so this cut. And it's this cut we need to kill. Yes. So we need to kill this cut. Not going to need that one anymore. And then this one needs to go way down. This was 0.6625 to this one only needs to be 0.1 because this is just a small countersink in this for the heads of these socket head cap screws are what mounts this thing into the motorcycle frame. And so this is just a small, like, 1/10 of an inch countersink to let the edge of the head sink down below the main mount, and that'll let you that basically clears that from any direct impact, which is kind of nice. Okay, this is looking a lot better already. What's this cut extrude again? Nope. Okay, so that's fine. I'm a little worried about this. So what we have here is this is going to be a through hole. So we're going to go open up here and open up our hole wizard here. And these are going to be just call them hex bolts. We want an M10 normal fit bolt through all. Okay, position. Oh, I don't want any countersink or anything. Just a straight through all hole. And then I don't want dowel holes, I need screw clearances. This is going to be an M10 screw, I do believe, here. And we'll just have a normal screw clearance. On that face. And I built this so this construction, all these centerline construction lines here, are where the foot peg is going to center on. So because we're getting rid of that boss, what we actually have to do is we'll just put it on this backside so it picks up this sketch correctly. What we're gonna have to do is actually bolt through this thing and try and hold everything together. So yes, we want that. Okay, so that's... I don't love that setup, but it's not horrible. What's this looking like here? So the normal distance here is 0.36. Basically 3/8 of an inch. That's awful close. And really, I mean, I guess that's more than 1/8 of an inch. It's basically 1/8 of an inch. Actually, I know what we can do. We can just pull up this sketch. No, I wanted the cut sketch. Exit this. this cut. We're just going to make this a driven dimension here. I just am curious what this dimension is, if I can get it to grab it. Okay. 3/6. Hold on. Let's get rid of this, and then I want to drag this up above this here, so that it shows up so that when I want to go measure this, I can actually go in and measure two various parts on this circle. We'll find a way to bring back sunlight. I mean, I guess that's 1/8 of an inch. That's decent. It's not going to tear out of 1/8 of an inch of steel, especially since it's like a 1/2 inch thick. Okay, I guess I'm just worrying about method here. And then the last thing we really need to do is clean up this cut, which is, I think, this one. So this is the circle we need to clear our brakes, our brake master cylinder, and then this was just kind of picked randomly. I just kind of like threw it together however I kind of felt like at this point. So, I think what I'll do is I'll get into this sketch here. And let's edit this sketch. Kill this. What else is it? Oh, that's what's messing with it. Okay, so I need to move that dimension. Okay, hey. Go back. Cool. So that should let me pull this where I want it to go. That distance. And then let's get normal to this. Let's get normal, people. Let's see if we can't add a tangency here. Nope. Undo that. Means we gotta go send it over here. That's probably fine. Okay, let's rebuild this and see what it looks like. Okay, and then we'll just hit this here. Fillet. Make that edge a little bit nicer on us. And voila! So now so this is the sketch that we had. What sketch is this? This is sketch 26. So we left this sketch in for a reason. And we left this sketch in because we're going to have to bolt this thing down at some point. We got to figure out where that is. What if we just bolt it down straight through this middle piece here? So we pick a line, let's call it, you know, parallel with this, and we just bolt it down straight through here. 2 bolts. It doesn't have to be big. These can be like, you know, M6s or something like that. Because, I mean, really, realistically, this piece here, this master cylinder mount, is not going to, is hopefully not going to see a bunch of stress in any sort of bending situation. So if we just like set actually what we can do is we can set it relatively in line. We'll just put it in line with this, mostly because that'll give us a little bit of side to side as well as, you know, kind of rocking motion. So control a lot of degrees of freedom if we offset them a little bit. Yeah, I think that makes sense. So let's go with Hole Wizard. times 6 by 1. We'll put through all for now. We'll see and we'll adjust that maybe later. I'm gonna pick this and pick like, so maybe like a position here and then a position like down here or so. Something like that. Legacy holes, nice. So this, what happens is it creates two sketches. It creates a sketch that is like a revolved cut in here, and then it creates a sketch here which is 2 point locations for those holes. So if you want to go in here and mess with this, you go in and edit this sketch here and provide some, actually let's go with, we just make a center line here to here, and then let's make this and this parallel, so that'll make those things move, and that'll keep this relatively in the center of the meat here. And then if we just put those to 0.425, pick a number, I guess. To orient like that.
Same mind, where you going back tonight? I saw a fire in your
0.875. Put it 7/8.
Where you going back tonight? I saw a fire in your bloodshot eyes.
0.875. How far does that push this fastener down? That should be fine. To be honest, that 0.375. Yeah, I like that better. It's more centered between these two pieces. Let's rebuild that now. See how I like it. Okay, this is not terrible. So then what we do here, so this is kind of the setup I think we're going to go with for now. So that gives us 2 mounting points for like a little bracket piece up here for our master cylinder, and then these are the main mounting points in the frame. This is the mounting point for the brake pedal. So you have your foot pedals here, and the brake pedal's actually up here somewhere, actually up here, and then it comes out and down somewhere out over in here in this area. It's for your actual actuation of the brake system. And then I think we designed this for socket head cap screws, is kind of the idea. So those will be pretty strong at M6x1. They'll be fine for this sort of application, I think. I hope so. We're using M6 bolts to mount parts of our crash plate, so this should be fine. Okay, so we'll save this for now, and then we're going to need to open up our olds, and then get rid of that, and then we need to open up the old prototype again. I'm going to turn that down just a little bit. Okay, so we're going to take this and save as. We're going to deal with the foot peg mount here. And this is foot peg mount V1. It's probably a more efficient naming scheme for this, and I do believe that I'm not using this at its full capacity. You should be able to save versions and then come back to a bunch of different versions of each piece, but here we are. So let's see. Whew. So this is a foot peg mount here, and so we want to keep this mount. Actually, let's open up this and see what these guys have to say about this. Alright, so looks like they're still charging $400 and some odd, even if it ships like in April. $424. Let's see what the charge is if we go run this. So we have it saved, so I'm gonna go throw this into Xometry here. since the add-in for Xometry isn't working right now. Hold on. I'll put this up here out of your guys' view for a second while I sign in. Okay. So if we go... and open up our CAD files here. Just doing this off screen. Foot controls, production, right side mounts, main plate. Throw this here. I do not want this to be made out of 3D printed material. If I wanted it 3D printed, I could make it myself. So I'll show you what we're working on here. So this is the Xometry interface. You can upload your file in here, and you can see this. I do not want 3D printing. I want CNC machining. Let's go by steel A36 because that's usually the cheapest. Yeah, see, look, this is now $90 by economy to manufacture, where the old one in the big setup, we'll save that and I'll show you what that one's like. This is the old prototype. You can see in the same setup it's $420. So just by chopping off all of these, what it really lets them do is lets them use a thinner plate. So that's much less expensive. They could use like a 5/8 inch plate or a 9/16 or something like that. Some like much thinner plate than like a 2-inch piece of plate. And they don't have to machine nearly as much out. They just gotta rough the outsides, clean that up, and then machine the insides. So this doesn't currently have the threaded holes, but the threaded holes are going to be roughly similar anyway. Because this part here, these two holes are threaded in this design. Whereas these two holes are threaded. So it's roughly similar in terms of threaded holes. So, yeah. Anyway, so you can see that we're, yes, I am not an arms dealer. We're already saving ourselves a huge amount of money. And I think that will continue once we get these parts also set up. So we'll delete this and take this off here. And now we're back in here. This is main plate. We can close that up now. And now we need our foot back up. Let's see. So what are we doing here? So this is the foot peg mount. So we've got to get rid of everything that isn't this, basically. I've got a really bad way of doing it, but it's a very quick way of doing it as well. So what we're going to do is we're going to just create a whole new sketch. Well, we're going to create two sketches here. So we're going to create our first sketch, which is we're going to sketch on this plane. And we'll get ourselves normal. But this is a really easy sketch because you literally just, this is this is 100% lazy CADing. There's probably a better way to do this, but it is the laziest CADing you can think of. So, we're gonna take a big frickin' square like this, just fix it in place. Oh, nope, I don't want that one. Let's get back to normal here. And then we're just gonna extrude cut. This is the laziest POS way of CADing this thing in the world. And we extrude cut through all. And so what you're gonna see is this gets rid of that entire section right here. So, and a 1, and a 2. I only want to keep selected bodies. We're just going to keep body 2. And ta-da! So, yeah, that's one way to do that. I don't necessarily recommend you do that, but that's one way to do so. Janky CAD 101 right here. Okay, and then really the only thing we need to do here, one, I can adjust this. I don't need this cut quite as aggressive. That is not that one. As this one. Hold on. Let's edit this sketch. I'm gonna get rid of the collinearity, and we're gonna go like this, and give ourselves a little bit of space, because this has been very hard. Okay. And then the other thing we're going to do is we're going to change how far in this goes. So that is... Okay, we'll rebuild this now. You'll see this, right? So, I probably want this to be filleted up here. And, I mean, this can be filleted. There's no reason. No, stop! Just add fillets. That's not gonna work. Okay, cool. That can just stay there. So this is here because there's the way this foot peg is if it hits the ground, it swings up in this way, and there's an arm that goes and slides back this way. So I just want to give it enough clearance to slide. So I think this will do it. We'll print this and check it out, and that'll go onto the regular YouTube channel content. But for now, we're gonna do it like this. It doesn't need to be like that. I would be okay with just minor radiuses in all the corners. It can be sharp edge. This is not a stressed area by any shape, in any shape or form. And then that fillet can go away. And then I need... No, that cut extrude is fine. No, I need this one. So we're going to change how this is. I think we're going to bring it back like 1/8 of an inch. So it's not up to surface. We're going to blind. Let's go 0.5. 1. 1.125. Okay, so that's about even with that. So, yeah, let's go with 1 inch here. Okay. That'll reset that. And so now this piece looks like it's pretty much ready to go. Oh, don't forget we need to add our hole here. So we need to add... Go into our hole wizard. This is going to be an M10 by... I mean, this doesn't really matter. So we'll just call out... Actually, I can check that right now. So I have the bolt right here that I would use. Where's my thread gauge? There it is. And this is my metric thread gauge. So that's the wrong size. Let's see what these are. Is it a 1.25, 1.25, or 1? Let's check the ones first. And so you just take this and try and fit it into the threads. That's not working. Ooh, 1.25. Fits like a glove. Alright. So, M10 by 1.25. And so this whole thing is like 1 inch and a 16th. Okay, so that looks good. And then we're going to select this face, and can we get that to line up? Just set it in there for now. And we'll go into this drawing and update that. So, first of all, I did that wrong. I did not want a through all, I wanted a depth. So this is not a through all end condition, it's a blind condition. So if we're dropping a 1/2 of an inch off of 1 1/8, then we need at minimum 5/8 of an inch. So we want to leave ourselves a little bit of space at the bottom because you won't be able to get threads all the way to the bottom. So if it's 3/4, that would be another 1/8 of an inch. We'll just put 0.875 in here for now. Oh. Maybe it is going to be a through hole. What if I put 0.75 in? Oh, interesting. That's just barely to that point. Okay. So we might be able... Actually, I've got this cut out on my bike right now, so I could probably update this. But, let's call it 875. And then we'll just min full thread depth of 0.75. I mean, if it's a through hole, it's a through hole, right? So, and then we'll go into this tap. So there's this location sketch here. So we'll edit this, and we'll make that point, and we can, that point are coincident. Yep. And we should be able to rebuild this, and hopefully that takes us out onto a flat portion. It does. That's good. Let's take this fillet. Let's get reasonable on this fillet. 0.1 is a pretty big fillet. 0.05. It's a 50 thousandths fillet. That seems fine. And then this is, that's a little unfortunate that the end of the bolt is going to be showing, because that's going to get really dirty in there, but it'll be pretty easy to get, you know, PB Blaster or something in there. So, alright, so we're going to say that's pretty good for now. We'll save. And then let's throw this in here into Xometry real quick and see what this part is going to cost us roughly, because this also has a threaded hole that we're not going to be able to call out. Well, that we can call out, but we have to provide a drawing to call out. So I don't really feel like providing a full-blown engineered drawing right now for them. This is mostly just sanity checking everything. Foot peg mounts. And then throw this one in here. Analyzing geometry. Alright, so this thing will cost us $97. So we're at $200-ish, $188.87 right now, whereas the old one was costing us $420. So by adding a couple fastener holes, we're gonna basically cut our cost in half. Could even make it out of 1018 without any real problems. What do we do? Nah, stainless is pretty expensive. Not really planning on welding it, so 303 is not bad. If I were going to weld it, 304 would be my choice. I wonder what this is made out. How much this is made out of titanium? Standard $1,000 made out of titanium grade 5. Um, 416 is not too bad. To be honest, if I were going to make it out of stainless, I might make it out of 303. But A36 is still the cheapest. So, what are their finishes like? Hold on. Standard. part is cleaned and deburred. Perfect. I'll paint it myself. Okay. Yeah, go ahead and save that. Okay. What else do we need here? Alright, so we're gonna make this piece now. So, yoo-hoo! Let's go pull up our prototype here. We need, right side mount V7. Here we are, old friend. One last time. And then we'll save as here. And we'll throw this in as the master cylinder mount. And this is MC mount V1. Okay. So, for this one, we have no need for this entire extrusion. Yes. Close. That can go away. Don't care about that one. None of these are necessary. Actually, for kicks and giggles, let's pull up the difference here. I need foot peg mount. Let's see what. Let's see if the plethora will even quote this one in 1018, or if it has internal corners that they say will be difficult to manufacture. Yep, it's going to be basically these internal corners, I bet. Oh yeah. Yeah, I've added a fillet. Okay, go away. So they aren't even going to quote that for me. But based on this one, where they are quoting me, and we'll go compare like to like. So let's change this to 1018 steel. So, plethora. For long wait time, let's call it, funny thing is, plethora, if it's shipped on Thursday, it would only cost like $130 more than if it shipped like a month from now. If it shipped a month later, it only cost $130 less, which is kind of ridiculous. So, one is the quantity. 1018 steel, and if we pull down the same part through Xometry, in 1018 steel, you can't see this. Hold on. You can see that right up in the top here over my head. We'll just See that? No, no, here we go. 96.77. So I don't know what's going on here, but these guys are quoting me April 8th legitimately 3.5 times less in 1018 steel. So I don't know what's going on, but this, I mean, yes, I'm saving 64.55 or something like that, for some reason, but that's some prices right there. So definitely shop around if you're trying to do some manufacturing on demand, because that's some ridiculous price changes there. Anyway, let's see. Let's go with we need master cylinder mount here. I don't need you anymore. Okay, so we need... I don't need that sketch anymore. At least not on this piece. I don't need that. Nor do I don't need any of that.
Know that your own light takes you there and keep shining so bright, and don't compare yourself to them. Yourself to them.
What's this fillet? Not necessary. I'm gonna leave that sketch. We can yet again get rid of this bevel. And get rid of this. We'll leave all these construction planes in here in case we need them. Okay, so this is going to be our major player here, this cut. If you want to see what the sketch looks like. Looks like, oh no, here we go. So this thing is basically what cuts out this this piece here. So we might have to add another cut back here. Once we figure out how we're gonna do this. But so this is gonna be a major cut here that we're gonna modify. So we're gonna keep that cut. What's this cut? Okay, so that's a cut we want to keep. Get rid of this. Okay, that one can go because I don't think we're going to have that sort of lip here. So let's delete that. We'll leave that sketch in place, though. Okay, so that's the counterbore sketch here for this piece. Okay. I mean, this can go. we'll declutter some of this stuff here. Don't need that. I would like to keep that sketch. Okay, so this is going to be an important... So this is going to be our pretty important sketch here. How are we going to set this up, though? This is going to be the rough one. This was always going to be the rough one. Kind of why I left it for last, and I'm kind of maybe regretting that just a bit. So... Okay, first things first, we need to reduce this boss extrude. So this whole thing needs to get reduced by 1/2 of an inch. Oh, I think I know how to do this. Do I know how to do this? We're gonna save, hold on. Before I go screwing anything up. Hold on. What was the... .0625 minus 0.875. Well, hold on. I'm an idiot. I just take this and subtract 1/2 of an inch. Okay, and that thickness is back to where we need it to be. So, what do we need to do here? We need to... I'm gonna need some like pillars or just a block that comes down and mounts in here. Not useful notifications on the phone. So this is the thickness that whatever stand... Oh, come on. So this thickness is whatever standoff we need. And so what we need to do is we need to adjust this cut to match the other one for now. So that would be that cut there. So we're going to go in here and adjust that sketch. Let's see, we need to delete this measurement, this measurement, and this measurement. Okay. And then we go in here and drag this onto that line. And what we do is we give this line and this surface the tangent relationship. No. Oh boy. How did I have that set up on the last one? Don't need anything about that. Main plate. What does that cut extrude look like? Oh, I put it on the end of the line there. Okay, that makes sense. You got the double coincidences there. Yep, that's what we did. Okay. Let's rebuild. And fill it. Just going to recreate this geometry for now. I think what we want is we want to cut from the top up here to leave whatever space we need. And then, yeah, I think that should be the plan. Yeah. Yep, that's the correct plan to have. So we're gonna sketch on this top plane here. Alright, how are we gonna sketch this? I think we're gonna go... Oh, no. Stop that. I didn't want that style of circle. I want that style of circle. I want this and this to be alright, so they already are tangent, and this to be tangent. Okay. So that's coincident, hopefully with that end of that point there. And then we're going to need to pull up the other drawing. Where are those holes placed again? Let's get normal to that. Let's get normal. That was a terrible song. Don't ever copy that. So that's basically 1.5 inches down from center line here. So if we go perpendicular to this, like, yeah, okay, so that's what we want to do. We want to go create a line here that's perpendicular to that line and intersects with this line. Well, let's do a little research here real quick. Xometry can go back into this quoting engine here. Fastenal. This is what I want. Right. These are currently specified as M6. So M6 by 1 socket cap screws. Steel, why not? They shouldn't need to be too terribly strong, but I don't think the... Now let's see, that's going to be... They're going to have to be... Let's call it... 20 millimeters? Does that seem right? Just short of an inch. 22 millimeters, 25 millimeters is basically an inch. So if I make them 25 millimeters, we'll take a look at their sales drawing here. So this is from Fastenal. If you're ever looking up fasteners, this is a pretty easy way to do it. Yep, submit. Okay, so we're going to countersink this, so we probably don't need a full 25 mil because the head is 6 millimeters. Okay. What about a 20 mil? Or an 18 millimeter. 18 millimeters feels right. Let's take a look. Okay, so this feels pretty close to correct. So this is the sales drawing from Fastenal, and this is just for an 8.8. This is an M6x1 18 millimeter socket head cap screw, and these are pretty good bolts, especially for these types of situations. So you look at it, this thing is, 6 millimeters here and 18-ish millimeters here. So overall fastener length is going to be 24 millimeters, which is just shy of an inch. So if we have a through hole threaded on our previous piece, then this is about the right fastener size, so it's not going to stick out the back. So that's what we're going to pick for now. And we'll close you. Oh, I didn't mean to close you. I'm going to need that reference. Because this side is going to be countersunk. So I'm going to need the head size in order to properly size that countersink. But so that head is 5 millimeters, which is... I should have been doing this whole thing in millimeters, but all of my measurement tools are in inches. So basically 200 thousandths, or 0.2 of an inch. So if we're at 1.5, we want to give ourselves what about 2? This, get out of this. They are perpendicular, and that should pretty much seal off that corner there. Alright. What do I have to do to fix that thing? There we go. Did I do something wrong when I sketched that line? Let's do it again. That onto this. there. Tangent. Okay, cool. Just trim this side off here, so I don't have to deal with that later. Okay. Let's make that and that perpendicular, because that's better for clearance on our brake pedal, and then we'll change that to like 1.75, because our brake pedal is going to come out kind of this way and down, so we want to leave a clearance here if possible. Okay, and then I think what we want to do here is then just, again, lazy CAD work. Go like this, go like this, go like this, and go like that. So what that's going to do, and then if we fix these ones in place, oh, we did it wrong. Good thing I stopped. So this and this. So what you want to do, if we're going to do this sort of cut the way we are, we're going to go like this. Oh, why is that? Yeah, go away. Out here, down over here, down over here, over here, and then back there. We're just going to fix these for now because these are just here to enclose the part that we don't want. This is all super lazy CAD, by the way. Sure. Fine, whatever. Alright, let's see what this looks like when we cut it. Not horrific. I'm not sure if this is needed, but don't really think it hurts to have that sort of mating piece here. And then what we need to do is we need to put holes in here. So let's put our hole wizard in. Alright, and we need this one. Counterboard. So hole specifications, these are M6 holes. Fit normal, hex bolt. No. Socket head cap screw, please. And then positions. We're just gonna put them like here and here for now, and we'll kind of adjust this stuff as we go. Okay, so there's that. You can see why we did this, because this now, let's see what this actually says. The normal distance is a 1/4 inch, so that'll let the socket head sit all the way back in. That's why we picked those 18 mil fasteners, because it should, give or take, be near the front of, near the back, but not all the way through. First of all, cut that. Yeah, I don't need that. Whatever that is, I don't need that. Okay. And now we need to go into this and recreate our measurements here. So we're going to create ourselves our center line. And that center line is going to be parallel with that edge. And then this is going to be, let's call it 0.375, I don't remember what it is. And then this is going to be 0.875. Is all this correct so far? Am I remembering everything correctly? Yeah, 0.375. And that's 0.875, and it's also 0.875 from the center of that hole. So let's see what that looks like on here. On here. There we go. And then we'll make a dimension from the center of this to that point there. 0.875. And we'll rebuild this and see what it looks like. I don't know if I like it being that close over there. Maybe I'll bring these holes a little closer together. .75. Make them 3/4 inches apart. See what that looks like. Okay, that feels better. It feels like there's more meat here on these pieces. I mean, this is basically just a bracket to hold this thing in place, but I do want there to be enough meat on all these sides that it doesn't feel like anything's going to tear out. So we'll save that. And then, not that, we want this. And we'll adjust this sketch here. this distance is 0.75. And rebuild. Alright. Save. Okay, so what we're going to do now is, for the end of this, we're actually going to throw it into our slicer. Here we use, I'm going to print this off my Raise 3D, but I use the same slicer for all of my 3D printers. We're going to go into Idea Maker here. This is, this profile is something I've been working on, like, for my dad, and just as, like, a business opportunity. There's some gold mining stuff out there, and people like to make their own mats for, like, sluices and stuff like that. So I'm developing some molds for people to make mats in. Alright, so now we're gonna go, is all that stuff saved? It is. So now quick save as STLs. So that we can throw these into our slicer. Our slicer doesn't take Solidworks parts, I don't think. I actually haven't tried. I've always just thrown STL files in there. So throw that in there real quick. And then we'll pop in here. Go into HyperTenere, foot controls, production. So one thing I already know that we're missing, and I'll show you when I put this thing down. We need a locator pin. Or something to locate and stop the foot control mount from spinning. So the problem with this setup is right now there's nothing to stop it from spinning. So what we're going to do is we might put like a little bolt or set screw or something like that we thread in from the back side over here. Or maybe we'll put like a pin or a dowel pin or something like that you set in one side and then you just bolt the other side in. I'm not certain. I'll probably talk to the machine shop and see what they suggest, assuming that they're going to get my business. So that's probably what we'll do. Just like a locating dowel pin. Okay, so there's that one. And foot peg mounts. Let's put this one in. This one's going to need a little bit of support material. And put this one in. This one also is going to need a little bit of support material. So these two are going to add supports. Just do the auto supports. I don't need to auto support that. Okay. Let's start the slicing process. Check our... Yep. Okay, cool. Yes. Yes. Cool. 5 hours from now, we'll have parts to kind of test out and see if they work. So, I'm going to leave this here, guys. Hopefully that was entertaining, maybe educational, maybe interesting. Let me know. So, thanks for watching, everyone. My name's Andrew. This is a Make It and Break It stream, apparently. Or on YouTube. This is a Make It and Break It YouTube video. We do stuff like technology-based manufacturing, so 3D printing, CAD design, and we try and help you apply that to your home garage and motorsports projects. So we have our Yamaha R6, which is the subject of this video, as well as like RX-8 that we're turning into kind of an all-races race car, and other stuff like that. So if that stuff sounds interesting, check out our YouTube channel, or if you're on your YouTube channel, definitely subscribe, ding that bell button, and hopefully you'll stay and watch more of the videos. Thanks for watching, everyone. Yeah, my name's Andrew, and I'll catch y'all later.